All right, peeps, here we go. Let's get this thing rolling. Right about there. That's good enough. All right. And oh yeah, I probably gotta do this or go to view. There's one thing I like to float on top. Yeah, something like that. All right, so here we go. 2.4 climate and biomes. Define these on page 174, 175. You can Google it. You can use ChatGPT, any sort of AI you want. I'm pretty easy. So, biome, climate, weather, way to go. Find them, nail them, all that sort of stuff. So, biomes, precipitation, temperature, insulation determine the environments. So, when you think about the environment you live in, a lot of it's dictated by just the amount of precipitation you get and the temperature. Yep. Also, the insolation, which is the amount of sunlight you have incoming as well. If you're up by the poles, you get less of it. If you're by the equator, it's more direct. So each biome has different biodiversity, productivity, plus limiting factors. So deserts and tundra, you tend to have a lot, it's a lot harder to live. So a lot less biodiversity. I'm going to put my hood up. It's going to make me look like an evil guy, but hey, we'll work with it. Or druid. All right. So why biomes are where they are. So climate determines what grows, what lives, and what, as a result, too, what grows and what lives determines what we do as human beings. Look at the food we have. Sure, globalization has impacted it, but a lot of it's what food grows locally and what you can do with it, what spices grow. How do you make it like yummy? And then what do you got to cook with? So, terrain, slope, aspect, altitude, latitude. This comes actually in with avalanches too, but let's stick with this more positive stuff. So the slope is like, okay, what's the angle at? Is it a high slope like that, high angle? Is it flat? A lot easier to grow farms when it's flat. Aspect, does it face, if you're in the northern hemisphere, does it face south? Because if it does, it gets lots of sunlight. That's very nice. Altitude, higher up it is, less likely farming is going to work out for you. And a general rule of thumb. A lot of good farmland, usually by the rivers. Why? For different reasons. So, latitude, distance from the equator. The further you get from the equator, generally the harder it is to grow. But don't get me wrong, deserts are a pain to grow in as well, and there's plenty of those by the equator. So, climate has weather patterns plus seasons to it. So, we take it for granted up here in New England and America that like wintertime is during the Christmas time. Guess what? If you're Christmasing down in Brazil, you're probably at the beach. So, and I'm probably jealous. So, Earth's tilt influences the temperature as well. I wish I had a good basketball or something around here. That might work. We'll see. Draw the Earth in a tilt, then draw it turning one day and going around the sun 1 year. Yeah. Yep. So increase the latitude or altitude. Increases decreased temperature. So the higher you go up away from the Earth, the more higher on the latitude, the colder it gets. The higher you go up in elevation, the colder it gets. So look at this right here. This picture shows snow in Hawaii. How is this possible? Yep. Right there, Snowy Peak on the beautiful Hawaii. Wind plus ocean currents distribute extra equator heat towards the poles. So, I'm going to get into this difficult stuff for this chapter. Talk about wind and ocean currents. So, tough stuff to actually get a hold of because it involves weather. And weathermen, you can be wrong quite a bit and still keep your job. So, wind plus ocean currents distribute extra equator heat towards the poles. Wind goes from high to a low pressure areas, so just like that. Wind forms with the ocean currents. Wind forms the ocean currents. So a lot of the wind, what it does is it comes down, it beats down on the ocean. The result is if you're near Puerto Rico or the Caribbean, you get some monster waves when we get snowstorms off in New England or any of these winter storms we have because they just pound the wind down on the ocean and then it's creates this current wave underwater. The result is you just get some curler breakers down by Rincon in Puerto Rico, and then Isabela in Puerto Rico as well. So a bunch of places. So let's get back to this and away from surfing. I do not surf. Wish I did. So both wind plus currents take the heat away. So, which is why usually when you're on an island or by the ocean, it's the wind will make it feel so much cooler than it actually is. So, summertime it's a lot more refreshing down by the beach. Call me crazy, I'd rather do summer in Jamaica or Puerto Rico where there's a nice ocean breeze versus in Hartford, Connecticut where we're in a river valley where it feels like a swamp between June and middle September. So, yep. Precipitation to evaporation ratio. P to E ratio. Yep. The P is for precipitation. The E is for evaporation. Got it? Yeah, got it. Okay. This is important because it shows how much water plants get. Heat can evaporate rain, then it's useless. So, some of those rainstorms you get in Jamaica or Puerto Rico, and you're like, oh, what a useless rain. It rained for like 5 minutes and now it feels hotter. It feels actually like stickier, more humid. Very true. So, the cold can freeze rain, then it's also useless because then it's locked up as ice. Yeah, you're dying of thirst, you're on a glacier, try chipping away ice for water. Not going to work for you. So, closer to the number one, the better for plants or soil. So under one is more is getting evaporated. All right, then it's actually getting absorbed. When you're over one, more is getting frozen, locked up. So there's only one person who likes frozen, and that's Elsa. She was in the movie. So productivity increases at low altitudes. What's more productive, a Jamaican rainforest or a frozen mountain in Greenland? If you can't solve that one, good luck to you with that IB exam. So, yep. Lower latitudes. Temperature is high all year. Yeah, man, it's warm. It's nice in the lower latitudes. There's a lot of sun. Plants love that sort of stuff. There's a lot of rain, too, so we got moisture for days. We're good to grow. Though when it does get to be a drought there, it's bad. 3 things above pump photosynthesis. So those things just make photosynthesis happen. So, which pumps the GPP, gross primary productivity, plus net primary productivity. You don't actually have to write this part down in yellow, but you do want to remember these terms. IB loves them. So, and actually, too, they work in with money, so you probably like them, too. Arctic, alpine, tundra have lower GPP plus NPP. Plus, throw in there maybe a desert as well. So, low temperatures, actually, maybe not desert. So, low temperatures, permafrost, ground always be frozen. Yep. Permafrost is like, we know this in New England, but like when there's no snow, but it freezes and you kick the ground and it's like if the dirt feels literally like concrete, that's like what permafrost is. Winter, lack of sun. So, yeah, in Norway, way up in Alaska, parts of Russia, they don't see sun during the winter. I mean, in the middle winter. Or if they do, it's very little. So, low precipitation. Cold air holds less moisture. So, yeah, man, a lot of those tundra areas, they don't get a whole lot of snow or like precip, but when they do, it locks it up. So, desert plus dry areas, lower GPP plus NPP. I knew I would work deserts in there because of the lower precipitation. Those are the 2 factors with it. They just does not precipitate. So you start to see why water and desertification really kind of takes a number on things. New England forest would become rainforest if precipitation increased, and we would become grasslands if precipitation decreases. We'd become like the Midwest. So, how many biomes are there? Well, let's take a look. There's aquatic, freshwater, swamps, lakes, rivers, stuff like that. Then there's the marine, which is the coral reefs, deep ocean, shoreline. There's deserts. Yep. There's grassland, chaparral. I don't know if I'm pronouncing that right. Hot and dry coastal shrubland. I've seen this before. So, forest, tundra, Yep, those are two as well. Climate change and biome shifts. So basically, with climate change, biomes are shifting. Coconuts are now growing in South Carolina in the United States, from what I've been told. So moving up the coast because it just keeps getting warmer. Fishing, fish keep that used to be tropical now coming up, towards New England. So the problem is climate change is occurring quickly and organisms change slowly. Plants change slowly. Animals can migrate, so animals might change a little bit faster. Organisms adaptation takes generations. Climate change is happening within your generation. Moving is the only meaningful quick change some organisms can make. Animals can make it, plants usually can't. Move towards the poles or higher up mountains. If you need colder climate, that's what you're going to do. Move closer to the equator for water. So if you're running out of water, keep going south to the equator. Migration, plants obviously are slower than humans. We talked about that. Natural obstacles too, because sometimes if you're a plant, your seeds are not getting blown over mountains, over large bodies of water, things along that nature. Human obstacles that are built there in your way: roads, farms, cities, bays, other things as well. So hotspots are areas predicted to have higher species extinction from climate change. So Himalayas, that can only move up, not towards the poles. There's no way you're making it from the Himalayas up to like Siberia. There's just too much land in between. So you gotta just move up a mountain, and you can only move so far up. So Eastern Africa, it's just very drought prone. So, yep, can't do much without water. And where are you going to go? Madagascar, it's an island. It's isolated. Where are you going to run to? Where are you going to fly to? How far is Madagascar from Africa? It's a bit of a migration for a lot of animals, especially if you can't fly. American Great Plains and lakes. So, yep. Climate change brings human opportunities into the environment. So in the environments, drilling for oil in the Arctic. Hey, it's not all bad, I guess. I guess you get to, get your fossil fuels out so you can burn them and create more for climate change. So, yep, hooray for that. Northwest Passage being free of polar ice would make shipping quicker, cheaper to the United States. Interesting enough, I think you got a lot of countries fighting over that right. So, at least I thought I heard something. Arctic undersea mining. So, no need to copy this. I'm not covering pages 181 to 187 in the book because we were going to be doing this in a classroom activity. But just so you know, if you're watching this and you're in a class that isn't mine, like, hey, if you're in an ESS class in Spain, in Brazil, Australia, some really cool place, all right, Mozambique, just know that you got to cover pages 181 through 187, which are not in the book. Which are in the book, but we're not doing them here. Climate. The sun at the equator is almost 90 degrees. Strong AF. If you want to know what AF means, that's not going to be on the IB exam. You're probably going to have to check up social media. So, yeah. Sun at the poles has a lower angle, gone for part of the year. Snow plus ice reflects, weak AF. So that's what we're talking about, insolation. So the difference in solar energy drives atmospheric circulation in 3 cell types: polar cells, Farrell cells, and the Hadley cells. So the difference in solar energy causes the 3 cell types to redistribute heat onto the Earth. Facts to know. Water can be solid, liquid, or gas. Boom. So hot air holds more water, which is one reason why you got more precipitation near the equator than you do way up in the Arctic. Liquid gains energy and becomes a gas, which mixes with other gases in the air. Latent heat of condensation is energy released when gas becomes liquid. So gas goes to liquid, condensation, boom, energy released. So Coriolis of force is the northern hemisphere. Wind blows west to east. In the southern hemisphere, it blows east to west. This is important. Look at your weather. Look at the map of like us in New England. We're always looking at storms coming out of the Rockies, going over the plains and whatnot. Actually, what we do is like we really kind of look to see if the jet stream points that storm down towards the Gulf of Mexico, goes sucks up moisture, and then basically pukes it down on us either as rain or snow. So, yep. Where was I? Oh yeah, Intertropical Convergence Zone, ITCZ. So low pressure zone near the equator, wind, no wind. So, Hadley cells. Let's get into them a little bit. So they're convection cells. From the equator to 30 degrees. So they're basically 1/3 of the globe. Both hemispheres. So, yep. Water is warmed and the water vapor created. So you basically, the ocean warms on up. You've got evaporation that happens on over it, which forms the water vapor. The water vapor mixes with the warm air, which then is going to make the air warm. So warmer. Air molecules move quickly upwards and apart, making it less dense, so hot air rises. Some cools and water condenses to form rain, plus clouds. Hot air is then pushed towards the poles, so it just goes northwards. Air then loses temperature. It increases precipitation, moves slower, and the molecules come closer, plus sink. This increases air pressure. So, yep. Air flows from high pressure to low pressure back to the equator. So it's like that cycle. So, what does this mean for biomes plus winds? The equator climate is hot and wet. Boom. All right. Strong winds called trade winds help merchant sailing ships cross the ocean. So, yep, back in the good old times of like triangle trade when we were trying to get from, not the nicest, but just, when you start looking at having a lucrative trade from England, you'd to have like a merchant ship would sail to Africa, would pick up slaves, would then sail across to the Caribbean. From the Caribbean would probably sail up to sometimes back to England. So it's like that, and the trade winds would help it out. It'd be quite a bit faster journey. So, let's see, where were we with this? Air flows, high pressure. What does this mean? Biomes plus wind, equators, strong winds. Okay, Ferrel cells. Convection cells as well. So weaker than Hadley plus the polar cells. It's like right in the middle. It's a weak old sandwich. So most air goes back to the equator. I think you'll find this probably from like 30 to 60 degrees. So, yep. But some flows away to form the Ferrel cells. Air goes from the high to low elevation at 30 degrees latitude, but slightly to the west. Air goes from 30 degrees latitude towards the poles at ground level, but slightly eastward. So if that confuses you, definitely look up an image of it. So then you've got the polar cells. This is the top, or towards the poles, those last 60 to 90 degrees. So of the latitude, north and south poles, 60 degrees, air still has some warmth and some moisture. So it elevates and goes towards the poles, where it definitely cools and it drops down onto the poles, usually as snow. Hopefully it was snow anyway. Poles equal cold, dry, high pressure. So air returns to complete the cycle. The northern hemisphere air flows slightly east. In the southern hemisphere, the air moves slightly west. So, yep, contrary to popular belief. Oh, actually, no, that one does. Yeah, sorry, my fault. Human influences on biome distribution. Humans change biomes for their purpose. I am not a product of my environment. My environment is a product of me. Humans, if we don't like something, we do something about it. We change it. So, example, New York City was a temperate forest. Like back in the 1600s. So, yep. Ocean currents and energy distribution. Ocean currents are movements of surface in the deep water. Ocean currents are slowing quite a bit in different areas, and they have a major impact. If they slow down or stop, big time problemos. So just so you know. Currents have moved in the same directions for hundreds of years. Surface currents are under 400 meters. I'm sorry, upper 400 meters. So you can figure that out, if you want to know feet, but you're probably looking at 1,200, what do you think, 1,400 feet? Anything from 1,400 feet to the surface is considered surface water. So, yeah. Moved by the wind. That surface one is just, boom, impacted by wind. Earth's rotation increases the motion as well. Deep water currents. Thermohaline. All right, tried my best with the pronunciation by that. Caused by different water density from salt plus the temperature. So, yep, it's kind of some cool stuff with the salt water plus the temperature, how you're going to get different water densities. So, warm water holds less salt, so it rises. And then you got that upswelling and stuff. So, define these for me, page 193, or Google, or use an AI. Use whatever you're going to do, but just give me some definitions. Upwelling and downwelling. You're going to use them pretty soon here. So you better own them. Let's put those right there, just in case anybody had doubt. Grab some water. Ocean currents and energy distribution. Cold currents that run from the poles to the equator. Humboldt's Benguela. I think I pronounced that correctly. Hopefully I did. So warm currents that run from the equator to the poles. Angola and the Gulf Stream. Yep, the Gulf Stream is one that affects us on northeast United States. So ocean currents and climate. Absorbs most of the incoming solar energy. So, yep, if you look at what water absorbs quite a bit. So, tougher to change water temperature than the air land, specifically heat capacity. Try this with like thawing out chicken. Thaw it out. If you got chicken in a freezer, take it out. Put it in the air. It's going to take longer to de-thaw. Put it in water. It thaws out a lot faster. So, warms, cools slower. So, yep. When is it better to go swimming in the Connecticut Ocean? June or September? September. All right. Snowstorms hits Connecticut. Who's getting more snow? Hartford or the coast? Hartford, because we don't have to deal with that like salty climate, over by the ocean. So, ocean currents affect climate. Gulf Stream warms Ireland, Britain, Norway, etc. Otherwise, it would be subarctic. So, that's why that Gulf Stream matters. It comes from the Caribbean right up to England. Norway, too, makes it kind of nicer temperature-wise. So, don't get me wrong. I've heard England, you get a lot of rain. Not going to lie to you, spent a week in London, though, and it only rained once. It wasn't bad. So, kind of overrated. So, we'll see. You can tell me I'm a liar, though. So, all right. Benguela current moderates the Nambian Desert. So, the Humboldt currents affect Peru, different ones. So, El Nino, Southern Oscillation. ENSO, Pacific Ocean. This is the Pacific Ocean and how it affects the weather globally. It's a variation in the Pacific Ocean wind plus surface temperature. It's near the equator. It's in the neutral stage. The El Nino stage is the warm phase. So La Nina is the cool phase. Normal winds blows warm Central South American water west towards Australia, Asia. So upwelling cold water replaces the warm. So, yep. Near the equator, neutral stage. Yeah, all that sort of stuff. So that's the normal stage. So that upwelling of cold water, it happens usually near Peru, makes it some like of the best fishing grounds around. So it's even better in La Nina. So El Nino, La Nina affect the wildfires, snow, rain, droughts, floods, just about quite a bit. So they're hard to predict. They happen irregularly, somewhere between 2 to 7 years. Every 2 to 7 year cycle, it's like, hey, we're due for an El Nino, all right, or La Nina. that lasts between 9 and 12 months. So when it hits, it's like, yep, buckle up. For 9 to 12 months, it's going to be like that. The Walker circulation is the weaker the east-west air circulations. So Walker cells are at the equatorial Pacific Ocean. Produces thermocline in the ocean. Circulates the ocean water up and down. Water temperatures decreases even more than normal with depth. So, yep, with the Walker cell. So it's like, the ocean's going to get colder as it goes down, but it does even more so with this. So, no El Nino La Nina, low pressure over Australia and Asia. Yep. Plenty of precept there. So, high pressure over Peru, Central America, not as much on the precip there. So the surface winds that go from east to west. Yeah, the warmer water plus the air is in the west. Warm air rises with the clouds plus rain. The drier, cooler air returns plus sinks. Yep, that's the way it goes normally. Now with El Nino, this is where we start getting a little bit spicy. So with an El Nino, we have wind weakens, then reverses. It goes the opposite direction. The warm water is Central America. Oh no! And it's flooding, and then crops die. So farmers are pissed. So there's no upwelling. The people here get really pissed because I would. No upwelling equals no nutrients. Because there's no nutrients, the fish die. Because the fish die, the seabirds die. So that's in Central and South America. If you're a fisherman, you are bumming. The jet stream drops south. So then there's more snow and rain in California, in Arizona, and less for Canada, Pacific Northwest, Alaska, stuff like that. They get less precipitation, so they got to worry more about wildfires. Australia, Eastern Africa, plus Indonesia is droughts, wildfires. Droughts are going to increase forest fires, but less diseases and bugs. Hey, they got to give you something, less malaria. So more precipitation in Central Europe plus Eastern Asia. Yeah, so hey, somebody gets something out of it. So yeah, if you're in Central Europe, the Rhine River cruises might do better. All right, maybe the Danube's a little bit fatter. Okay, good stuff like that. Fewer hurricanes and cyclones in the North Atlantic. Cool. All right, could definitely do without those as much. So El Nino, hey, there's some benefits to us, like Eastern United States and in Europe, but rest of the globe kind of it is not too happy. La Nina. La Nina is the wind strengthens, pushes more warm water east to west to Australia plus Asia. Upwelling by Central America, more nutrient-rich water plus coastal fog. More nutrients for fish, more seabirds, more happy fishermen because of big catches and big moolah, big money. All right. More coastal fog though. Hey, so if you're in San Francisco with the La Nina year, probably going to get more like fog delays, fog accidents, stuff like that. Jet stream goes north, so that's going to be less snow and rain for California. Ooh, kind of wildfires and stuff in Cali, that more likely. Arizona too. So yeah, Alaska, Pacific Northwest, Canada, British Columbia, stuff like that. You're going to get more snow, more precipitation. Cyclones are more severe with the La Nina. Okay, just the way it goes. So, local and global effects of the ENSO. Ocean temperatures get affected of it. Ocean current speed gets affected. And also the global weather patterns, as you can see. The human impacts on ENSO are this. More peeps now. So there's more people, more problems. More respiratory issues because there's more people respirating. Issues from forest fires. So famines from crops, flooding, drought. More mouths going, wow, hungry. All right, more people out there to feed. So when the crops die, that's just more people starving. Political, social unrest. If you want to see starving people, what do starving people then do? They then want to take it out on somebody, which is usually their government. Or crime, stuff like that. So boom bust of fisheries. So like with La Nina, like fisheries are like, oh yeah, dude, gonna be great, can't lose, making tons of money. Just, like hauling $100 bills in right over the into the boat. Now with La Nina, it's like, I'm sorry, with El Nino, it's like, oh no, you can't even catch a fish. Don't even try fishing. Doesn't even pay for the fuel to go out. So, so it's kind of like gorging versus starving. So I wish it was more constant for the fishermen on Peru, Ecuador area. So more insects and diseases. The more precipitation you have, the more you're going to have insects. More insects, more ability to carry those insect-borne diseases. All right, El Nino in 82, 83 to 97 and 98 caused severe droughts in Australia, Indonesia, the Philippines, typhoons in Tahiti, flooding in Chile, empty fish boats. Again, no, not happy fishermen. Nope, not happy at all. So let me move that down. Let's talk here about tropical cyclones. When we talk about cyclones, it's basically, it includes hurricanes, typhoons, and cyclones. So they counterclockwise north of the equator, which means like that. And it goes clockwise if it's south of the southern hemisphere, south of the equator. So it's they can be like up to 10 kilometers high and 600 kilometers wide. So they move 25 to 100 kilometers per hour. It originates in the tropics, low pressure center with wind speeds over 119 kilometers per hour. Called different names depending on where they are. In the Atlantic and the Northeast Pacific, they're called hurricanes. Northwest Pacific, typhoons. South Pacific plus Indian Ocean, cyclones. So how are cyclones formed? Near the equator. Heat, basically. Warm ocean water makes air warm plus rise fast. Cools, then pushes aside more warm air. This is a convection current. It gets convection currents going there. It's a thunderstorms, stuff along those natures. Thunderstorms group together, usually by the eye, causing a low pressure depression, eye of the storm. Water vapor cools, and then it releases rain and energy. So warm air further lowering the air pressure. So this is kind of one of those cycles that just keeps self-perpetrating. It's like more hot air rises with warm air forming vapor from the ocean. It's a never-ending storm. It just keeps powering itself until you go over land, and then the temperature drops, and then hopefully the storm dies out before making tons of disasters. Intensity and frequency of the tropical storms. Global warming is increasing intensity plus the frequency. All right, now look, there is evidence for this and there are doubters. So I do want to show both sides of the argument because we are IB and you can make up your own mind. Here's some evidence for you that these cyclones, hurricanes, typhoons are having more damage and more of an impact. Look, higher sea levels. Fact. Water's risen. It's higher than it ever has been before. So because of that, the coastal flooding is going to be worse. Fact. Ocean warming increases evaporation. And as it increases evaporation, it then increases rain. Fact. So, yep. Northwest Pacific cyclones seem to be shifting more north. That's not fact. It's just an observation. So increase the population is going to increase property damage plus peeps affected. More people you have, there's more people affected. And there's more people living in an area. It's more property going to get damaged because these people live in houses now. So more houses to get damaged. Fact for that one. Look up what states have the highest home insurance cost. Where does Florida rank? I gotta be honest with you. I thought Florida would be number one and it wasn't. So, yeah. But generally getting home insurance in Florida, from what I've heard, is difficult. And even if you can get it, you're like, okay, if the hurricane happens, will the insurance company just declare bankruptcy before I can get my settlement money? So, got to think about these things. Here's some evidence for you from the doubters about, use these analytics, about the increasing intensity and the increasing frequency. So, right here is the intensity of major hurricanes from 1900 to 2024. This is off of drroyspencer.com, just using his stuff. Just looking at this, look, all right, wind speeds. So we've got 1, 2, 3, 4, and the worst one was Labor Day, and that was all really before 1960. So, 1900, 1960, so that's 60 years. Now you throw 60 more years onto it. Over here we got 1, 2, 3, 4, 5. So we got 5 storms that are really above that average line there. And as far as frequency goes, number of major Florida hurricanes, I know they have this line going up to here, but if you look, 1900s, 1910s, 1920s, 1930s, literally you're pretty steady right across it, right up until you hit the 1940s, and the 2000s were just a bad decade for it. And so you look all right, every 60 years it looks like a bump in it. We have a bump right here. We've gone from 2 to 3. So that's average per year. So I'm sorry, number of major hurricanes. So we've had 3 in the last decade. So that is a bit of an uptick versus 2, but nothing like what you'd blow your mind apart, sort of data. So there's your evidence. You guys can make up your own mind. All right, right here. Let me make this a little bit smaller so we can read off the whole thing. All right, map of California with climate graphs from Crescent City and Desert Center. So, Desert Center, right here. It's probably pretty hot there, hence the name Desert Center. Crescent City, way up by the north, probably cooler there, especially because it's right on the ocean. So, all right, precipitation levels right here, temperature right there. January, February, March, April. All right, so the gray bars are going to be the precipitation levels. So precipitation is lowest in the summer months, and it's wettest during the winter months. It's also, too, right here, the temperature, low and high. It's going to be highest during the summertime. Yep. Now, precipitation right here in Desert City, as you can see, precipitation levels, pretty darn low the whole time, but it's lowest right in the start of summer. Yep, and then for precipitation, and the temperature is highest during July and August. So, all right. Now we got that covered. With reference to figure 2B, was that 2B up there? Oh, yeah. Outline one difference between the climates of Crescent City and Desert Center. If you listened to me, you probably have it. If you didn't listen to me, you should have. So this is figure 2C right here. With reference to figures 2B and 2C, state the biome found around Crescent City. Well, considering Crescent City's right about there, you're looking at that dark green one. Yep. All right. Figure 5B, number of individual wildfire events and total area burnt in California, 2013 to 2020. Let me get that a little bit smaller there too. Yep. So, number of individual wildfire events and total area burnt. So, area burnt, low, dang. Low, really low. Ah, really bad, 2020. All right. Number of wildfires. Okay. Plodding along. So that's the highest right there. So a wildfire in 2021 which burned area of over a period of 103 days. Damn, 1/3 of the year. Wow. State the trend in number of individual wildfires. Pretty static. I'd love to tell you that they were increasing, but they were increasing 2013, and then they were down. Your average is probably right along here. Yep. Okay. With reference to 5A and 5B, so that's 5A and that's 5B. All right. Suggests why the area burnt in 2020 was greater than the area burnt in 2013. It could be drought. All right. Explain how wildfires act as a positive feedback mechanism for global warming. Describe the process of cessation of a wildfire has occurred in the forest. After a wildfire has occurred in the forest. Explain how the process of cessation leads to changes in productivity. With reference to 4 named agricultural strategies, outline how they improve the sustainability use of soils. And with reference to named examples, compare and contrast wild fisheries and aquaculture systems in terms of their efficiency and environmental impacts. Yeah, and we're down to 2.5, so that's good. All right, everybody, do awesome. Thank you for joining me. Y'all get a high five. All right, now let's see if I can turn this thing off.